I'd like to introduce you now to a construct called atomic variables, which is very closely related to object-based isolation. So here's the idea. Suppose we have an array of documents, an array X from 0 to n minus 1, maybe n is of the order of 1,000,000, and each document could be really large, and we want to process these in parallel. So we've seen earlier that creating 1,000,000 asyncs, it depends on the implementation, but there could be overheads involved. So instead, what we'll do is we'll create a for all loop that only goes for a smaller number t iterations, where maybe t is of the order of 100 and n is of the order of 1,000,000. And we want to divide up the work of 1,000,000 documents among these t parallel iterations in the for all. Well, we've already learned about loop chunking, so we could chunk the space of 1,000,000 documents across these 100 or so for all iterations. The problem there is these documents could be of variable sizes. Some could be really short, some could be very, very long. So just breaking it up into equal numbers of documents may not be the best, because some for all iterations may end up with all the large documents, and the other iterations would end up waiting for them. So instead, there's a work sharing model that's often used by parallel programmers. And it looks something like this. Each for all iteration would repeatedly track a current integer to indicate the current document, and it'll update current by 1. If current exceeds the number of documents, then we can break out of this loop. Else we can process the document. Let's say j is the current over here. So we can process x sub j. Now, the issue, of course, is that these iterations are running in parallel. Current is a shared variable, so you could have data races. So what you can do is put this in an isolated construct and use that for all the iterations to coordinate and determine which iterations are executing which documents. In this way, as they go through the while loop, and they can keep repeating this until they break out of the while loop, so you could put a while true over here. It could be that I equals 0 ends up getting half the documents if they're all really small. Some other for all iteration might just do a small number of really, really large documents, and that will just work out through this work sharing. Now, this kind of pattern, especially with integer variables, is very common. So many parallel programming models introduce the idea of atomic variables, and in particular an atomic integer. So if you have an atomic integer, and if you declare current to be an atomic integer, you can perform an operation such as current dot get and add. What it does is it adds 1 to current and returns the previous value before the addition. And it's implemented in a way that many parallel tasks can perform this operation safely without data races. And the observation over here is this isolated is not a general isolated. It's isolated on the current integer, which is the only integer being incremented. So a very efficient way of implementing object-based isolation over here for integer variables is to use atomic integers. So what we are seeing over here is this model of object-based isolation has been used very often in the past and has been encoded in special purpose libraries such as atomic integers. There are also atomic references that implement some interesting operations on pointers such as compare and set. And understanding atomic variables is simply a matter of understanding object-based isolation, And having learned object-based isolation, you can work with atomic variables from any parallel programming language and use them in your applications.